Hello everyone, myself Hans. Today we are going to solve the problem of UPSC 2013 from Indian Forest Service examination. Here in the question, solve by method of addition of parameters, and the differential equation is given by d2y upon dx2 minus of y is equal to 2 upon 1 plus of ex. Let's solve the problem. Given differential equation is this is given by d2y upon dx2 minus of y is equal to 2 upon 1 plus of e to the power x. We have to find the auxiliary equation of the differential equation. We have to find auxiliary equation of the given differential equation. This is given by m square d2y upon dx2 denotes m square and minus of 1 is equal to 0, and from here we get m square is equal to 1 and m is equal to plus minus of 1, and we have to write complementary function of the given differential equation. This is complementary function is given by c1 e to the power of x and plus of c2 e to the power of minus x. Here are the roots of plus minus 1, so we have to write in the form of, let this is equation 1, and further let y is equal to v1 y1 plus of v2 y2 be the particular solution of particular integral of, let y is equal to v1 y1 plus v2 y2 be the particular integral of the differential equation. So from here this gives y1 is e to the power of x and y2 is e to the power of minus x, and we have to find v1 and v2, and v1 and v2 is given by, v1 is given by integral of minus y2 upon w into r dx, and v2 is given by integral of y1 into r upon w into dx. Here w is the Lorentzian we have to find here, and r is comparing the differential equation with dy upon dx2. This is the form of, like, this is y double dash plus of py plus q is equal to r. Here is the r is, from here r is equal to 2 upon 1 plus of e to the power of x, and further we have to find first w is given by y1 y2 and y1 dash, and here is y2 dash. We have to find here y1 and y2 is given. We have to find y1 dash and y2 dash. This is given by y1 dash on differentiating with respect to x gives e to the power of x, and y2 dash is given by on differentiating y2 with respect to x, this gives minus of e to the power of minus x. We have to put here y1 is e to the power of x, y2 is e to the power of minus x, and y1 dash is e to the power of x, and y2 is minus of e to the power of minus x. We have to solve on cross multiplication with e to the power of x. This gives minus of e to the power x and into e to the power x, into e to the power x, and here is minus. We have to again multiply it with this gives e to the power of x. Once again, e to the power of x into e to the power of minus x. And from here, once again, from here we can also solve. This is once again from here minus of e to the power of minus x and plus of, when base are same then power are add, then minus of x plus of x gives 0. From here we get e to the power of 0 is 1, and here is minus is already present, this is minus 1. Similarly from here this is also gives, the base are same then powers are add, then from here plus of x and minus of x, this gives e to the power of 0, and from here is minus, so this gives minus of 2, which is not equal to 0. And further we have to put in the equation. We have to write a complementary function here. Complementary function is given by c1 ex plus of c2 e to the power of minus x. And further we have to find v1. v1 is given by y2 minus of y2. Here is minus is outside taking. y2 is here e to the power of minus x, and r is given by 2 upon 1 plus of e to the power of x, and w is here minus of 2 and dx. Further we have to solve first. v1, this gives minus and minus is plus, this gives e to the power of, once again, 2. 2 to 2 is also cancelled out, and minus minus is also cancelled out, then the remaining is e to the power of minus x upon 1 plus of e to the power x dx. E to the power of minus x, y2 is given by, and r is 2 upon 1 plus of ex. And further we have to solve. We can also write, that is v1 is equal to integral 1 e to the power of minus x taken to denominator, this gives 1 upon e to the power x into 1 plus of e to the power of x and dx. Further we have to break in the partial form. We can also write, that is, this is 1 upon e to the power of x minus of 1 upon of 1 plus of e to the power of x dx. When solving, taking here LCM, this gives e to the power x bracket 1 plus of ex, and from here this gives e to the power of x multiplying this 1 plus of ex and minus of ex. This gives 1 upon e to the power of x bracket 1 plus of ex. Further we have to solve. We can also write here, this is this. When we let here the particular solution of differential equation, here we have to write, this is y is equal to v1 y1 plus of v2 y2. This is the particular solution. We have to rough here. And further we have to integrate. This gives integral 1 upon e to the power x taken to numerator. This gives e to the power of minus x dx, and here minus of, from here we have to take common e to the power of x is taking common. E to the power x is taking common. This gives, once again, e to the power of x is taking common. This gives 1 upon e to the power x plus of 1, and this is dx. And further we can also write, this is On integration of e to the power of minus x dx, this gives e to the power of minus x, and once again and again minus of x differentiating once again, this gives integration of e to the power of minus x. This gives minus of e to the power of x, and from here one e to the power of x is taken to numerator. This gives integration of e to the power of minus x upon, here is 1 upon e to the power x is written as e to the power of minus x and plus of 1 dx, and from here we can also write, here we have to write the value of y1 and y2. This is y1 is e to the power of x and y2 is e to the power of minus x. We have to rough here. This gives v1 is equal to e to the power of minus x and minus of log e to the power minus x plus 1. When solving this, let e to the power of minus x e to the power of minus x e to the power of minus x plus 1 is taken t, so we have to get here, this is minus of e to the power of minus x dx is equal to dt, and so we have to replace here. From here dx cancel out here, this is plus, minus is plus, and log of e to the power minus x plus 1 this gives, and further we have to find v2. Once again here is minus is, and further we have to find v2. v2 is given by integral of y1 is e to the power of x, and r is given by 2 upon 1 plus of e to the power of x upon, here is w is minus of 2. Further we have to solve, 2 to 2 is cancelled out, and this gives minus of e to the power of x upon 1 plus of e to the power of x. We have to let 1 plus of e to the power x is t, so we have to get here log of t, v2 is given by minus of log 1 plus of e to the power x. This is the value of v2, and putting in the particular integral we get the, first we have to put in particular integral. This gives y is equal to v1 is minus of e to the power of minus x plus of log 1 plus of e to the power of minus x into y1 is given by e to the power of x v1, and plus of v2 we have to calculate here, minus of log 1 plus of e to the power of x and here y2 is given by e to the power of minus x. This is the particular solution of the given differential equation, and we have to write complete solution. We have to write complete solution with the help of complete solution. Complete solution is complementary function plus of particular integral. So we have to write here, complementary function is c1 e to the power of x plus c2 e to the power of minus x, and the particular integral is given by here, this is minus of e to the power of minus x, and once again e to the power of minus x plus of log 1 plus of e to the power of minus x into e to the power x, and minus of, once again, this is minus of log 1 plus of e to the power of x into e to the power of minus x. This is the complete solution of the given differential equation with the help of method of variation of parameters. Thank you class, and thank you for watching.